I'm going to give you a few hints and tips for working with a normal distribution, a way of sketching out the problem to help you see what you're trying to estimate, and it should help you um, know which function to use. Should you be using the norm.dist function or the norm.inverse function? So I'm just going to revisit these problems that we looked at in the lab uh, assignment or lab practice. So we're going to estimate these probabilities for Tesla returns. So we're just going to be looking at Tesla right now because you did the exact same thing for Microsoft, where the sample mean was 4.34% for Tesla returns with a standard deviation of 18.03%. And when we use the normal distribution to estimate probabilities, we are assuming the variable is normally distributed with this mean and this standard deviation. So we're assuming those are the true mean and true standard deviation, and it is normally distributed. Even though in the sample we can see from that distribution of Tesla returns that it's not actually normal. It's something. It's got more skewness. It's got a long right tail. Mean's not equal to median. It's not normal, but we're assuming it is for this problem. So we're going to revisit these problems right here, where we want to find the probability that the return is less than 0 if it were truly normal with this mean and the standard deviation, greater than 5%, and between 5 and 15%. So what we want to do for a problem like this is, I'm just writing down what we know. So we're going to assume this was a sample mean, this was a sample standard deviation, but we are going to assume the returns are normally distributed, and this is the true mean and this is the true standard deviation. So we're assuming this is mu, this is sigma. If you want to find the probability that the return is less than 0, what I recommend doing for anytime you're finding these probabilities is to sketch out the problem. So we're just going to sketch out a normal distribution, identify the mean, which is 4.34%. That's the mean. And we want to find the probability that the return is less than 0. So we know it's going to be somewhere over here because this is 4.34%. So let's just put 0 right here. And this is the probability that we're trying to estimate right here. So this right here is what we are trying to find. And since the area is on the left tail, and we know it's the left tail because this is pointing to the left, we know this is going to be a norm.dist problem. So we would use norm.dist to solve this problem. And then we're going to put 0, our mu, so our 4.34%, our standard deviation, 18.03%, and we always do true. So when we do that, so if you look here, the way we found that was norm.dist, 0% was the value of x, h2 is our mean, h4 is our standard deviation, and we put true, and we get the answer to that problem was 0.4. So the probability that the return is less than 0 is 0.4 when 4.34% is the mean and 18.03% is the standard deviation. But when you sketch it out like this, it helps you see the problem, know what area you're looking for, and we know it has to be a number less than half because for a normal distribution, half the distribution is less than this number, and half is greater than half the area is to the left of 4.34%, half the area will be to the right. So if you did this, got a problem greater than 0.5, got an answer greater than 0.5, you know you're doing something wrong. So if we want to do the probability that the return is greater than 5%, do the same thing. Sketch the distribution, put the mean, 4.34. 5% is greater than this, so we know we're going to be over here somewhere. And we want the area to the right of that. So that area, that line right there is at 5%. So we know we want the area to the right. So that's the area that we're looking for. But since the norm.dist function gives us the area to the left, we know we have to do the 1 minus the norm.dist. So this is going to be 1 minus norm.dist. Then I'm not going to put the numbers in there, but the first argument would be the 5%. So it's always your x, and then your mu, then your sigma, and then option true. So anytime you see the shaded region on the right side of the distribution, you know you need to do 1 minus norm.dist. Because norm.dist is actually going to give you all of this area over here that's not shaded. 1 minus that would give you the area to the right. If we're looking at the probability of being between 10 and 15%, again, sketch that distribution. That distribution will be centered at 4.34%. That's your mean. And we're looking somewhere over here between 10 and 15%. 10%, 15%. And we're looking for the number between those, the area between those two numbers. So that's what we're looking for. So anytime you see a shaded region between two numbers, you know you're going to do a norm.dist twice. You're going to do a norm.dist on the 15%. That's going to give you all of this area to the left of 15, but we don't want the area to the left of 10, so when you do minus the norm.dist on the 10%, it's going to subtract all of that area out. So this was going to be a norm.dist on the 15 and then a norm.dist on the 10, which is exactly what we see here. We do the norm.dist on that 15%, and then we do the norm.dist on the 10%. And that's going to give us the area that's in between those two numbers. Now, if you're working a problem that is the bottom 10% or top 10%, we're working the problem backwards. So in this case, notice for all of these, we're looking for the area. So for all of these, we're looking for this area to the left, this area to the right, or this area in between. When we're working a norm.inverse problem, you still want to sketch the distribution. It's going to be centered at 4.34% because that was, and that's our mean right here. But when we're trying to find the return that represents the bottom 10%, so we know it's the bottom, so we're going to sketch this area over here. We know that area is 0.1. This is now the number that we're looking for. We're trying to find the number that corresponds to the 0.1 being to the area of 0.1 being to the left. So this is a norm.inverse problem. So this would be a norm.inverse. You put the area, 0.1, and then your mu, and then your sigma. So when you're working this type of problem, notice the first argument we enter is the 10%, which is the same as 0.1, because that's the area to the left. And then H2 is your mean, H4 is your standard deviation. The top 10%, we solve it in a slightly different way. We sketch your distribution. 4.34% is where it's centered. But now we want the return so that the area to the right is 0.1. And now we're looking for this number. Now, if you enter norm.inverse 0.1, because that's what your shaded region is, you're going to get the wrong number. So if the area to the right is 0.1, then we know that all of this area right here if the area to the right is 0.1, the area to the left has to be 0.9 because the total area under the curve has to be 1. So if you're trying to find the top 10%, you'd have to do a norm.inverse. But instead of putting the 0.1, we're going to do the 1 minus the 0.1. and then you put your mu and your sigma in. So you have to make sure if you have the area to the right, there's a 1 minus inside the norm dot inverse for this type of problem. 1 minus norm dot inverse is never correct. Norm dot inverse, you do the 1 minus inside of the function. So working the problems like this and just drawing the distribution, highlighting the region that you're trying to find will help you figure out if it's a norm dot dist, a 1 minus norm dot dist, a norm dot inverse, or 1 minus norm dot inverse. So anytime you have a shaded region to the left, or you're in between two numbers, like this one right here, it's a norm dot dist. Anytime you have a shaded region to the right, it's a 1 minus norm dot dist if you're trying to find a probability. If you're doing the norm dot inverse type problems, if the shaded region is to the left, it's just norm dot inverse. If the shaded region that you're looking for is on the right, or if the shaded region that you're given is on the right, you're trying to find this upper value right here, you do a 1 minus that area right here. So that should help you stay on track, not make silly mistakes when you're solving some of these norm dot inverse, norm dot dist type problems.